Hey, hello and welcome to today's GFG problem of the day. Check whether BST contains dead end. Given a binary search tree that contains unique positive integer values greater than 0, the task is to complete the function is dead end, which returns true if the BST contains a dead end, else returns false. Here, dead end means a leaf node at which no other node can be inserted. So let's see through an example, right? What the problem has to say. So, for example, right here, let's take this example. Here you see, right, this tree, right, wherein this one is a dead end. Okay, so what do we mean by dead end? Here, what they're saying is dead end means a leaf node at which no other node can be inserted. So here you see it's a leaf node at which no other node can be inserted. The minimum value, right, which can be inserted in BST is positive, unique positive integer, right? Unique positive integer. So minimum can be 1, right? And maximum, if you see, 2 is already there, right? 2 is already there. So here no other node can be inserted into its left and right subtree, right? Into its left and right subtree, because 2 is already there and 1 it's minimum. We cannot insert 0 here, right? Because they're saying the BST can only contain unique positive integers, right? So this is a dead end. Another example here you can see, right? Here you can see this 9 is a dead end. This 9 is a dead end. Why? Because see 10 is already here, right? 10 is already here. So 10 cannot be inserted here, right? 8 is also there. 8 is also there, right? So anything greater than 8, anything greater than 8 and less than 9 can be inserted in the left side, right? In the left child, as a left child. But 8 is already there. Anything greater than 8 and less than 9. So less than greater than 8 and less than 9, right? So left child can there cannot be any left child over here, and right child as well. Anything less than 10 and greater than 9. Again, there cannot be anything in the right subtree, right? As a right child, right? There cannot be anything as a right child because, right? Because 9 is already here and 10 is already here, right? So that is why this is a dead end. Okay. Okay. So how can we solve this? So let's see. Let's write a pseudocode for this, right? Let's write a pseudocode for this. For example, what we do, let's say we call is possible, right? Is possible. For example, node, we have a node root and int min and int max. Okay, this is a function, right? And uh so let's if we pass this, if we pass the root, right, root 8 to this function. This is a function call. We pass the root, right? And what can be the minimum value? 1. And currently we don't know the maximum value. Maximum value can be anything, right? So simply we'll pass max integer, right? Max int, right? Max int will pass. Okay, so here, for example, let's see now. Yes. So what we'll do, let's take an example here. It's 8, 5, 9, 2, 7, 1, right? So what we'll do, we will, whenever we go to left subtree, right, root dot left, right, we'll have to traverse, right, root dot left, right? What we'll do, we will have this root dot data minus 1. For example, we'll start from here. We'll start from this root. We'll write the pseudocode later on. First, let's see what we can do, right? We'll start from this 8. And then first we'll traverse the left subtree to find the dead end node, right? So when we go to the left hand side of this, when we go to the left hand side to 5, so what we'll do, we will first of all, we will, when we go to the root, right, we're going to pass minimum and maximum, max int, right? Max int, right? It can be a big number, this maximum possible value in integer, right? 1 and max int will pass 1 as a so what all possible values can there be, right? What in the left and right subtree, right? The minimum on the left hand side can be 1 and the maximum on the right hand side can be maximum integer value, right? Maximum integer value on the right hand side of this 8 in the right subtree, right? When we go to the left, 1, and what we'll do, we'll simply when we go to the left, we will simply do this 8 minus 1. We'll pass on 8 minus 1, 7. So what it will say as the maximum value, right? The maximum for this 5 node. Okay, what can be the minimum value? on the left subtree, it can be 1, and the maximum value on this right subtree can be 7, right? So yes, because yes, definitely all the left subtree for 8 will have 7, will have maximum, right? Anything will have values lesser than 8, and maximum will be 7, right? So when we again go to the left subtree, right, we'll pass on the minimum as is minimum, and what we'll do, this root dot data, right? When we go to the left subtree, 5 minus what all possible max, what can be the range, right? What will be the range for this for the left subtree and right subtree for this node? Okay, so the range can be, the minimum range can be 1, and the maximum range of node can be 4, right? So if we go again to the left, whenever we go to the left, so we'll pass on minimum, and we will root dot data minus 1 will do. Root dot data minus 1 will do 1, right? So what all values can what all values can the left and right subtrees of this node can be? 1 and 1, right? 1 and 1. 1 and 1, which is already here, right, in this node. So no other values can be inserted in the left and right subtree. This indicates what all the minimum value in the left subtree, and this indicates the maximum value in the right subtree. So here, see, these both are same. These both are same. So and this is also leaf node. So this is a dead end node. We cannot insert. We cannot insert any node in the left and right subtree of this one, right? This is a dead end, right? Because the minimum and maximum are same here, and 1, which is already there, right? Similarly, we can see another example as well, right? Let's take this example, uh, this one. Yeah, let's do one thing. Maybe let's copy this. Okay. So what are we going to do? We'll start with this node, right? With this root, and what all values are going to be the minimum value, right? Which can have in the left subtree will be 1, and the maximum max int will pass, right? Max int, right? And then we'll go first to the left subtree, right? We'll go to the left subtree. So when we go to the left subtree, what we're going to do, we are going to decrement 8 minus 1, 7, right? 8 minus 1, 7. So this will be the range of the left and right subtree, right? The minimum value and the maximum value. We'll go to the left again. So here this time it is going to be 1 and 6. Root dot data minus 7 minus 1, 6. So this 2 can have values 1 and 6. So this is a leaf node, but nodes can still be inserted, right? 1 can still be inserted here, or values from 3 to 6 can still be inserted here, right? So this is not a dead end. So for example, let's go to the right subtree of this, right? So when you go to the right subtree, right? So the maximum, right, on the minimum value which can be inserted into the left subtree can be 9, right? Root dot data 8 plus 1, 9, and max int. Max int. On the right hand side, right? The BST property. On the right hand side, the value will be greater than the root, right? So there's no such range as such, right? Maximum can be anything. So max int will pass. Okay. But when we go to the left now, left subtree of this. So minimum will be as is, right? Minimum will be as is. And what is the right range will be 10 minus 1, 9. 10 minus 1, 9, right? So here you can see this minimum maximum is same, right? Whenever it is same, and here also it is 9. So no other value can be inserted. If you see anything here in this left child, what can be the value? Less than 9, but greater than 8, right? There's no difference, right? 8 and 9 is already there. So left child cannot be inserted. Here, if we go greater than 9 and less than 10, again we both have these values. So this is a dead end, right? And if you see what will be the pseudocode quickly, let's see. Will pass is possible, right? Is possible, right? Root, and minimum will be 1 for the first time. We are going to pass this 8, right? Minimum will be 1, and here integer dot max value, right? Or in C++ case, it can be max int, right? It can be max int, right? Or, yeah. In Java, it will be integer dot max value, right? Now, if you write the pseudocode for this is a function call, and what can be the pseudocode is possible. I won't write complete is possible. For example, right? Node root in Java it will be like this. Node root in C++ it will be asterisk, right? Right. So not much difference. Int minimum for this minimum, right? Int maximum, right? Is possible. Now what are we going to do? First of all, let's first see the function calls. Return. There'll be two function calls. Is possible or is possible. First we'll go to root dot left, right? And then we'll keep the minimum as is, right? Minimum as is, which will be 1, right? Which will be 1, right? On the left subtree. And the maximum will be root dot data minus 1, right? So how? So see, if you see, right, whenever we go to the left, what are we doing? Minimum we are keeping as is, and maximum this one, right? This one, root dot data minus 1, 8 minus 7, right? When we are going to the left of 7, right? Minimum we are keeping as is, this 7 minus 1, 6, right? Root dot data minus 1, root dot data minus 1, right? Or, right, we can find dead end either in the left subtree or in the right subtree. So wherever we find, we'll just return true, right? Is possible, root dot right, right? And then what will pass on here? Root dot data plus 1, and max will be as is, the maximum integer, right? The maximum integer. So if you see here, whenever we are going to the right hand side, what we are incrementing the minimum, right? The left subtree will be, right? If when you are going, when what we are doing, root dot data plus 1, 9, and max and we are keeping as is. Whenever we go here as well, so minimum will be whatever it is, uh, root dot data plus 1. So 11. Definitely this, after, for this right subtree will contain minimum 11, right? Which will be greater than 10, right? Which will be greater than 10, definitely. This is the BST property, right? And max int. There's no limit to the maximum range, right? It can be anything. Max int, right? So here we are, what we incrementing, root dot data plus 1, root dot data plus 1, 10 plus 1, 11, right? So here we are passing, sorry. So root dot data plus 1 and max, right? And if you see, what will be, first of all, if the base condition will be if root equal to null, then simply return false, right? Simply return false. Then if, see, whenever there is dead end, right, the minimum and maximum value have been same, right? If it is this case, return true, right? This is the dead end, return true. So whenever we saw, right, here in this case 9 and 9 were same, 9 and 9 were same, right? For this 9, see, minimum maximum value were same, right? In this, that means that in this 9 subtree, the minimum and maximum can be 9 and 9 only, and 9 is already there, so no other value can come in this left subtree. Similarly we saw here as well, right? 1 and 1, 1 and 1, the minimum and max value were same, 1 and 1, right? And 1 is already there, so no other nodes can be inserted, or no other values can come in this left and right subtree, right? So yes, so this is the pseudo code. Let's quickly see the code, which is almost same, which we have written. Okay, so here what we are doing, definitely if it is root is null, right? There's no single node, then we are simply returning false, right? There's no dead end. Then what we are doing is possible. We are passing root, minimum can be 1 and maximum can be boundless, right? It is boundless. It can be anything, right? So this is left and right, right? And what we are doing, we are passing here is possible root dot left. We are keeping minimum as is, and maximum we are decrementing, right? We are decrementing. We saw this. And when we are going to the right subtree, right, we are incrementing this minimum, root dot data plus 1, and RL. Maximum we are keeping as is, right? Minimum, it is, in this case, the max will be definitely less than the, on the left subtree, right? Less than the root node. And here the minimum will be greater than the root node. That is why root dot data plus 1. And here we are checking if it is equal, then return true, right? If it is equal, then return true. So let's submit. So this is the Java code. In C++ also, it's not going to be much difference, except for the fact that we'll have to pass asterisk over here, right? Right, asterisk over here. And the this max value will change. It will be max int, I think. Yeah, max int. So not much difference between Java and C++ code. Yeah. So thanks for watching. Please like the video and subscribe to my channel. It will motivate me. Thank you so much.